So in question 6b, we've been given this triangle and we're asked to solve it, which means solve for all the sides and angles. But what we've been given is an angle, a side, and a side. So angle, side, side, we have to worry about the ambiguous case, because this length of 8 can be oriented in this direction, which gives us an angle here which we're going to call C1, and an angle here which we're going to call C2. So there are two different triangles to solve for. So we're going to first start off with this triangle here. Well, we're going to solve for the angle and see what angle we come up with. So I'm going to set up the sine ratio. I have sine 50 over the opposite side length 8. And then we're going to set it up as sine C over the opposite side 10. And what we'll end up doing is we're going to solve for this angle, and we're going to call that C1. So solving algebraically for this, I get sine C is equal to 0.95, approximately 8 when I round it. The angle C, which I get from my calculator, I get 73.24 degrees. Okay, so that's going to be my C1, 73.24 degrees. Now, we have to bear in mind that there is an alternative triangle that can be drawn, and we'll solve this later, but that angle is going to be C2, and that's going to be this one right here. We'll call that one C2. And to find C2, these two angles are related in that they are supplementary to each other. So to find angle C2, we're going to take 180 degrees, and we're going to subtract the 73.24 degrees. Sorry, this should be 25. I'm just going to change that because I need to round that correctly. 25 degrees, and we're going to subtract that angle, and we get 106.75 degrees. So 106.75 degrees represents the angle that we're going to end up in here. Okay, so we'll solve that separately. So going back to the original triangle that we're looking at now, I've got C1. I need to calculate the angle here, which I'm going to call B1. So angle B1, if I subtract 180 minus 50 minus the 73.25 degrees, I'm going to end up with, looks like 56.75 degrees. Okay, so that's 56.75 degrees. Okay, so there's my side length. I'm going to calculate the opposite side, which I'm going to call B using the sine law. So B over sine of 56.75 degrees is equal to a known pair, so 8 over sine 50. Okay, so then putting this in my calculator, 8 times sine of 56.25, or sorry, 75, divided by sine 50 gives me a side length of 8.733, or I'm going to round that to 8.73. So B is equal to 8 times sine of 56.75 over sine 50. And that gives me a length of 8.73. Okay, so this length here is 8.73. And at this point, I've solved for all angles, all sides, so I've solved this triangle. So that's the first triangle. We need to solve for the ambiguous case as well. So I'm just going to sketch in the ambiguous case, the alternative triangle based on the theta 2 that I solved for. When I solved for C1, I had to find a theta 2 or C2. So drawing it in like this, my C2 exists like that, and that angle is 106.75 degrees. And so I need to solve for, and this is a length of 8 in here. Okay, so I need to solve for B. I'm going to call that B2, and this angle here, B2. Okay, so I'm going to start with the angle B2. So angle B2 is going to be 180 minus the 50 degrees minus the 106.75 degrees, and that gives me an angle of 23.25 degrees. So using that angle, I'm going to solve for the side length. So B over sine of that angle opposite, 23.25 degrees, is equal to, and I'm going to take the same pairing, the pair of 8 in its opposite angle, 50 degrees. So my B2 value, the side length, is going to be 8 times sine of 23.25 over sine of 50 degrees. Okay, so typing that into my calculator, the sine of, let me just type that in, 23.25, and I get a B length of 4.12. Okay, so that side length of 4.12 then completes the second triangle. So I have all three side lengths and all three angles inside that red triangle here. So let me just write that in. So that's 23.75 degrees. Okay, so this is an ambiguous case. So there are two different triangles that need to be solved for. All the side lengths and angles for one triangle are in black, and all the side lengths and angles for the second triangle are in red.